Have a good day, my friend. If you look at this, you see the same hot side cold side uh, separation uh, in a black line, big thick black line shows the which is the hot side, generally arrow towards the cold side, right? And really each of the element understand the each of the element is important, but when it comes to troubleshoot, first start with the power hot side, because generally the uh, failure rate of the cold side is less than the hot side. Therefore, first you need to start troubleshooting from the hot side. If you see these 2 points, these are the power connection that direct 230 volt AC comes in, and set of air gaps placed in case of a lightning or uh, lightning strikes or something happened. The some safety recommendations that is given for the switching mode power supplies or any power supply, those are there. And after that, this power rails goes to via a fuse here, and this power doesn't directly uh, send to the bridge rectifier, because some kind of since the switching power supplies, the internal harmonics are very high. The harmonic can uh, go to the other devices in the house or other houses. Therefore, line filters has been made via a inductor, 2 inductors in series, and this power up the bridge rectifier. This is the AC side, and these two are the DC outputs. These DC outputs directly taken out to that Infineon IC to work in a switch mode, and this is the Infineon IC. Actually, I did a repair around this. That's why these wires are. But in the original PCB, this wire is not there, and there was a damage in the PCB. Then I repaired it, and this Infineon, if I zoom it a little bit, let's have a closer look on the switching IC around that. This is ICE3BR 1065JF coal MOS, and it operates the entire power up entire the switching primary side. And if you look at the data sheet of the same, yeah, it is a offline SMPS current mode controller with cool MOS, which is a product name. We shouldn't worry, it is a MOSFET anyway. And startup cell, and in full pack it is. Really, if you read through these instructions or the data sheet, you will get a in-depth understanding. It is really cool features that they build Infineon company. If you, I'm not going to explain every bit, but let's look at the typical circuit diagram. That is the same circuit that the Samsung has been adapted to their TV. And there is a line, as we saw this C bar, it is the capacitor we talked about, and some kind of snubber, which is a diode, which when generally drives via MOSFET, we put a snubber so that the high voltage spikes on the or the reverse current that appears on an inductor in case of switching, it we can absorb from the snubber. And really, this is the primary side operation that MOS is doing. There's a PWM controller which drives the MOSFET's gate, and with that the switching happens in this winding. When initially powered up, the due to the start of this switching, there is a secondary voltage it generates um, on this side, on the same side. Like it is kind of a normal transformer. It works like. we have seen in many places the simple transformers, like there's a primary and secondary. It gives kind of a voltage to output, and it is the voltage that governs the entire circuit within the IC. And yeah, there are the components we can deep dive later. This is the um, optocoupling I mentioned from the secondary side to primary side, gives the voltage feedback of all the secondary voltages. Really, this is taken from one, but if you look at the real circuit, it takes from all the voltages in a different way, actually, not that the way we think, but it is a good way of handling decoupling. And that according to that feedback, the pulse width of the frequency that generates through the PWM controller changes. With that, the voltage, output voltage, gets stabilized. And also this works in two modes, active burst mode and auto restart mode. These are cool features that give from the cool from by Infineon.